Hello everybody, I'm Alexei Kraborov, the founder and organizer of SF Scala, and this is our last meetup of 2016. We're at Clara, which is our new member, so we're kind of moving up and up, and I think it's a very good way to close out the year with Bill Venners, one of the, I would say, fathers of Scala locally and internationally, the author of the famous Scala book, which we'll use. And so I think we're kind of celebrating many things. We're celebrating the third edition, which came out this year. We've seen a huge intake and impact of Scala this year, and obviously we're a new company using Scala. So I think this is all good reasons for us to chat with Bill. So,
all right.
Hi Bill, it's great to have you back with us. So third edition, we didn't really have kind of a formal book party, and we'll use this as an opportunity kind of to see what's new in Scala, right? So the book is noticeably bigger. I have it in my backpack.
Oh.
I hope you can sign it. And I learned Scala from that book, right? From the first edition, and then I had the second edition, and I had this PDF. I was still a student, so I don't know if you remember. You gave me a nice discount for claiming to be a student, which was true, but you didn't verify anything. And and the PDF is super awesomely crafted, right? It's not just any PDF, and I think it's probably one of the reasons in my mind that Scala is actually adopted as much, because it's actually just a perfect book on programming, right? It's not just a book on Scala, it actually reads very nicely, right? And so I just wonder, if you can tell us what's new in third edition, again, how did you manage to catch up with all this? Is it harder or easier every time when the fourth edition is coming out? Do you know already? So tell us, kind of everything about third edition.
Okay, sure. Well, first, thanks for saying all those nice things, and it's nice to hear that because we worked really hard on making it accessible and making it a great piece of writing. The reason it was hard to do the third edition is because Scala actually did get adopted to enough of an extent that everybody was really busy. So what we actually, I just had a conversation with Martin at Scala Exchange last week that we were talking about maybe we should just do one every release, like just instead of like when it feels like the right time to do it, just go ahead and do one every year and a half, because Scala releases come out 1.5 years, and it might be easier to do the update. But since ours had gotten pretty stale, it was 5 years since there'd been a new edition.
Yes.
Just because we couldn't keep up. We actually overshot Scala and covered 2.12 in the book before 2.12 was released. So it was a little bit risky, because what if 2.12 changed, right? They might have changed what if meant between the time we'd have to. But they didn't. It actually is still accurate to 2.12, and now it's the most up-to-date book. And I think because it is kind of a resource for everybody, it'd be good if we could try to do that, and then it would be a smaller step each time. So hopefully we can achieve that. But yeah, it was, for me, I mean, just personally, it was so hard. For so many years I've been wanting to get it out, and I couldn't quite get it all finished. So it was really nice to finally get it out the door.
So every writer, has the different techniques. So I like, so there is this program on NPR called Writer's Almanac. Garrison Keillor does it every morning, right, at 9 a.m. Like it's a 4-minute chunk. So so the bird is of different writers, and usually sometimes he mentions their techniques. Different writers have different techniques, right? Some of them kind of start with the last sentence and go backwards. Some of them work and kind of. So I wonder, like, is there anything in your technique? How did obviously you're a speaker, right? You consult, you have a lot of things going on. Still, you managed to find the time to write and update this big book. Like, is there any special tricks?
No, just put in. For me, it was just finding the time to put in the work. But I don't think I'm really good at writing. Like just writing something once, I have to write it badly, and then rewrite it a bunch of times, and really do that a lot for me. Other people, it just comes out pretty nice, earlier on. But the other thing that I learned from Bruce Eckel, he's wrote a lot of books that were pretty popular on C++.
Thinking
and Java.
Thinking in
C++, using Java.
Atomic
two big books. Right, he wrote Atomic Scala, that's right. He said, read it out loud to yourself, and if it sounds funny, saying it out loud, then maybe it's not conversational enough. I mean, the kind of, it depends on what you're trying to achieve, because what I wanted to achieve was just a conversational, friendly tone. So that's like what I would tell you about whatever it is I'm trying to explain in person. That's how I wanted the text to come out. I mean, the reading feeling to come out. So that's one thing I would do sometimes, is read it out loud to myself to see if that sounds natural.
Interesting.
Yeah, but I learned that from Bruce. He gave me that tip years ago.
I mean, I know that you do a lot of training, right? So you interact one-on-one with people, and I can tell, right? Like, we have many talks at the conference and meetups, and your talks are one of the best delivered, right? And kind of the clearest, right? So are you kind of trying to? So you're very effective in person. So I kind of you're speaking this aloud. You're trying to kind of translate that into book form. What works in kind of interpersonal communication?
You just wanted it to be not confusing, I think. I mean, the public speaking was not natural, or at least when I was a kid, I was very shy, so it wasn't. I was terrified of that, but somehow I got, or it didn't matter. I don't know how that happened exactly, or where that happened, but yeah, I think in the book I was thinking about, it was the first book our team had ever published, so I got books on typesetting, and I wanted to make the typesetting beautiful if I could, and kind of artsy. I mean, as best you can do with LaTeX. Yep. Which LaTeX is really like the best way to typeset technical material. You can really make it nice. So, but anyway, I think it was more really try to squeeze out anything that could be confusing to people, like especially things that sounded like partial functions and partially applied functions. They aren't. They're completely different things, but they sound very similar, and that's confusing to users, right? But that one we couldn't change. I asked Martin if there was another name for that, but he said, they're really traditional in the academic literature, so we should probably call them that. So we did. Yes. But there were other things we changed, names we adjusted to, like not calling val value and var variable. We didn't do that because val really is a variable also, like f of x equals x plus 1. X doesn't change, but it's a variable. So things like that we were very, very, very painfully particular about, to just try to not avoid. When you're reading along, you get mixed up. It's like, well, what do I mean? So that's what in the writing, that's what we try to do. So what are the new major additions to the third edition? Well, futures, which was kind of funny because we wrote about the future of the future, which you might want to, well, like we haven't come out yet, but they added a bunch of stuff to future. Well, first of all, in the old edition, in the second edition, we had a chapter on actors. It was Scala actors, but that had since been deprecated and replaced by Akka. But Akka is really like not Scala; it's a thing on top of Scala and Java. So it didn't really make sense to put it in the book. But futures had been taken from the Akka project and brought into Scala since then, and they're just great, right? So I like them a lot, so we wanted to put a chapter. We replaced the actors chapter with the future chapter, but into 12 they added a bunch of nice methods to future which hadn't come out yet, but we documented those as well. So that was like the future of the future, the future of the future, and the future of the past. And then just updated with everything. Got rid of the procedure syntax. A bunch of little things, just so that it's up to date, and. Like we didn't show view bounds anymore, which I don't think is officially deprecated, but it's kind of discouraged. And we talked about context bounds, and type classes more, which because they had since come into favor as the more preferred way to do that kind of thing. So I have some examples. It's just basically brought it up to date with what's in the language and what's accepted as more best practice, I would say. Interesting. So obviously, Scala is used for many different contexts, and I think until a few years ago it was mostly used for things like play. But now we see a lot of adoption of Spark. So I wonder if that influenced it in any way. It's influencing Scala. In this edition, didn't really come into play there, I don't think. But at least Martin has talked about some of the methods that they added in Spark in the data structure, the distributed collection, are kind of nice, and I thought maybe we should put those in Scala collections, but they haven't yet.
So I have this radical view of Spark. Essentially, I think Spark is basically just distributed Scala. So I think Spark does its job very, very well.
Yeah.
You don't notice it's there. Basically, you have your Scala prompt, and instead of just a single machine, there is a giant cluster.
Yeah.
But if Spark does its job really, really well, it should just disappear, right? And so I think the initial success of Spark was based on Scala Collections API, right? It's basically just took Scala Collections API, literally, made them, the distributed collection behave in the same way, right? So I think, it's kind of, the book does a really good job kind of explaining the collections, right? And I think in kind of the long term, if people know them, they can just apply, right? But there is this whole rise of data, right? And kind of essentially SQL-like methods and data frames, right? And then of course all this data science thing. So I wonder, do you have any inclination to kind of see how Scala is used in this context and follow it in the future?
The one thing that I felt was that the old way, imperative way of dealing with collections of things, like you have an arrays, you'd use a while loop and go through them.
Yes.
So they kind of all have to be there. Whereas the functional way was to get rid of, it's error prone to write a loop and an index and all that, so you move that into a method, a higher order function like find, and then you just pass in the bit that was different every time you wrote one of those loops, which in the case of find is what you were looking for, like a little predicate. And then that's a little bit of behavior. So if you, and it's done, that was done that way to make it less error prone. You're not writing a bunch of loops that you might make a mistake each time. You have that all inside these higher order functions, and you just pass in the little bit of behavior that was different each time. But because you're doing that, then you don't have to have the whole collection there anymore, right? If it's distributed across 5 other JVMs, you could, and you can serialize that little bit of behavior, you can send it and have one piece do part of it, and another piece do part of it, and another piece do part of it. So I thought it was kind of like it fell out of, because it was the functional style where functions were first-class objects, you could pass them around, pass them as parameters. That also happened maybe by just, well, I don't know, I mean, I didn't sort of foresee that, but it also meant that it could be just serialized and sent and chopped up into pieces. And if you look at parallel collections, it's the same kind of thing, even though it's on one JVM. You chop it up in pieces, and it's a little easier you can send this behavior, not serializing it now, but you can have parts of it done here, parts of it done here, and then you reassemble it. That was the only kind of thought I had, was that it was the functional approach that enabled that.
Which is big, right? Which I think, kind of to me, Scala basically is MapReduce on one machine in the small, right? But Spark is kind of MapReduce in the large, right? And Scala is kind of, it teaches you to deal with that, with the data set as a whole, right? So you don't have this, which iterates through, right? So which is you still are using in Python, right? Like it's not still natural to use lambdas. You have to use them. You can use them with Spark, right? That's good there, but I think it's kind of So I wonder about this other thing. I think your book is actually kind of a first book for many people for Scala, right? And maybe the first book of functional programming, right? Because of Scala's special nature. So I just wonder, like, if over the course of years, like, what are kind of observations? Like, there are new people coming into functional programming, right? And they use your book. So do you see this as going easier? Is kind of functional programming becoming more mainstream, or is it still a lot of imperative people kind of still struggling with this new world?
Well, what came to my mind when you asked that question was that we wrote it in 2000, let's see if I get this right, 7 and 8. And there was nobody using Scala, really. I mean, it was this teeny tiny little potential future language that people might use. And so the target market was Java people, because they were feeling some pain of verbosity and a bit of, it had been a while since much had happened in Java land. So we really did target it at imperative Java, but you're familiar with Java and that way of doing things. And we would compare to Java a lot. And I think one difference these days is that a lot of people aren't coming from Java now. People coming from data science aren't. So the comparison, this is like Java, that's like Java, all through the book and footnotes. Like, it makes sense for Java people, but it may not make so much sense for everybody. That's how it's different. And they are, I still think functional is, most people don't have a lot of background in that or a lot of practice with it. most people. I mean, there's always definitely people came from Haskell because this was on the JVM, but despite you hear from them, I think most people don't have a functional background still today, but it's just they also don't have a Java background necessarily. That's what's different.
And Ruby, somebody told me that Ruby developers make better Scala programmers than untrained Java developers.
That could be.
Or because they share the same interest in beauty and conciseness.
Okay. That's interesting.
Right, and they have these little closures.
Yep, they
right,
do.
so kind of they have this little variable that pass into them.
Yeah.
Right, so they already have a lot of background.
Yeah.
Right, and so a lot of them go to the closure, but I think Scala shares a lot of values. Right, so I think like it's in this kind of modern world, right? Maybe they're not into functional programming directly, but they are kind of conditioned, right? Like little things they can pick up.
Yeah, that's interesting because way back when, prior to me discovering Scala, I was kind of feeling the tug of wanting a new language after Java that was more concise, but I didn't want to give up static typing, and I didn't buy the dynamic typing as the future, sort of marketing pitch of these consultants who wanted to sort of stake their business on that.
Yes.
And what I had observed is that what people like about Python, what people liked about Ruby, were actually functional things like blocks in Ruby, or in Smalltalk have the same thing.
Yep.
List comprehensions in Python. I was like, well, yeah, but that's actually a functional thing, and so that was like, oh, that's interesting. And then the other thing that I felt about Ruby is I really did like their taste. They had really nice taste on code and beautiful code, and I really tried to emulate or honor RSpec when I designed some things in Scala tests because I just thought they did it really nicely there. And Cucumber also. It's like that's also from the Ruby community. And it's just always very clean. The code, that's like English, but right. So that actually did influence Scala test, at least the Ruby aesthetic, I think.
Yes.
Because I thought it was. I also agreed with what you just said. They have a nice. Well, I just think they have nice taste.
They have a good taste.
Yeah.
I was fortunate to meet Mats, the inventor of Ruby. He gave a talk recently at the Microsoft Reactor, and it was pretty interesting that he still focuses on basically on style and
making people happy.
Making people happy.
Yeah, he doesn't care about how fast it goes, unless that makes you unhappy, I suppose. But I met him too. I interviewed him years ago, and he is that was the most humble, nicest guy.
Yes.
Yeah.
So this is interesting. So obviously, I think it's a nice kind of transition into Scala tests, right? So we're going to talk about the essence of testing. First of all, thanks for coming in this rainy day. This is the essence, right? Like the weather tested us, and I think the strongest people will come.
Yeah, I know.
So I know. I think it's kind of another question I would ask about the Scala test and Galactic, right? So you keep developing Scala tests, and so Galactic is kind of a separable library, right? Which you can use outside of testing, and it reflects your own learning of a lot of different things. So I'm kind of curious about your take on, right? So we see a lot of really involved functional programming presented at Scala by the Bay, right? So every year new things are becoming mainstream. So Freemanad was last year, and a lot of new things this year. So it's kind of every year we up the level of complexity, right? And that kind of spreads through the kind of most advanced tribe of Scala people, right? And so in Galactic, I think you really do a good job of kind of taking what kind of works for you, right? And make it available. And when you look at it, it's really clear, and it has excellent Scala doc and examples, and I think it's kind of a learning. So I'm almost waiting for you to learn all these things.
Yeah, I know, that's funny.
So it's kind of to me it's like a little kind of threshold, right? Like hurdle. Get into Galactic, then we'll look at you. So I just wonder, like, what do you think about this interesting progression that Scala is kind of a testing ground for all these new FP concepts? They're kind of some of them spread in the mainstream, some of them are not, and then you decide to put them in Galactic. So can you tell me, like, how do you decide what to learn? How does it make its way into Scala test and into Scala?
Right. Well, I don't know. I think it's somewhat intuition and just like it is. over time I learned, and then I realized, oh, actually this would be better. But then I deprecate that. I mean, I think one of the reasons people use Scala test is it's also very stable. I do make changes, but I do them slowly, and you know, if I actually realize I screwed up, or not screwed up, but I want to change what something means, I deprecate that. It still works for a year or two, and then, you know, there's a warning, and then you switch to a different name, and then I changed it after that, right?
Yes.
So, but yeah, Galactic was just, there's certain things people asked me for that made sense to put into in the test framework that they also wanted in their production code. So I said, okay, I'll have this one that's tied together. And it has grown over time, and it is like functional object-oriented programming. It's kind of a little bit like CATS or Scala Z, but like some of the things they do, like a type-safe equality or validation, or there's something in there called any-vals, which I'm going to show tonight. Which there's something in type level called refined, which it's done. Mine's in the Galactic way is a little more object-oriented, and the refined way is a little more Haskell-y. I mean, it comes from Haskell. It's more at the type level. But there's like address some of the same use cases, I would say. But I think, you know, what you described there is true of Scala still. And I remember years ago, I heard someone say about Scala that it's still small enough that it has interesting conferences. It's a lot bigger now, but it still has really fascinating conferences because everybody's doing so many interesting things. All different kinds of experiments. So some of them, you know, won't end up being the way we end up. But I think that's just what's really exciting about it, is just that people are all trying different things. And so what I'm kind of going the functional object-oriented way, where I say, well, it's not Haskell on the JVM, and it's not Java without semicolons. It's this middle thing, this new thing. And how do you really combine these two? I mean, yeah, that's what I'm trying to find, I think, with Galactic. And I think CATS, and it's more, people really love category theory and math, and they want that to be at the center, whereas I think most mainstream folks can benefit from some of that stuff, but they don't really want that at the center. They want something more domain specific.
Right. They want stuff which works and passes the tests.
Yeah, and it's more domain specific. It actually reads like, and see, that's one of the things the Ruby folks did, because they didn't have many types. They sort of had to make the code read like what it means, you know, what you meant. And I think even though with the types, you can still have like nice types that even have mathematical contracts, laws and that sort of thing, but they still actually read like text, and it sort of says, oh, okay, I kind of get what's going on. That's what I think was missing from the Scala Z approach. It was just way too mathy. As far as the resulting code, people would look at it and they see all these squiggles, they have no idea, they just really can feel lost, you know, like most people. So that's what I'm trying to like find a way to actually get the benefits of it, but still the code is accessible to everybody.
Yes. So
that's what Galactic
like the test read as a spec, right, as a description of what they do. And I think you know, you achieve this goal, right? You work hard on doing this, and I think it's there. So we'll probably, you know, I can ask you endless questions. So we'll probably, you know, like a whole bunch of questions I'll ask you maybe next talk. But I want to ask you two questions to wrap up. So one is, I remember part of Scala test update was this major effort to do Scala.js.
Right.
So, you know, looking back a few months and how much it took, do you think it's justified? Do you think Scala.js will be adopted, and this effort people put into compatibility, is it worth it?
I don't know. I wondered halfway through if it was worth it. And I don't know how big Scala.js will be, but the effort, it did two things. One is it postponed a lot of things that I wanted to do, so that was kind of bad.
Yes.
But the good thing is it actually helped me understand what the test framework really was, because the JavaScript was so different than the JVM, and we had to do so much disentangling from the JVM that then we sort of learned there are some things that were forced upon us that actually makes the whole thing better, even on the JVM. So I think it was worth it to do it for that purpose. But and now we're just having a lot of fun doing. We're starting to catch up on those things. Some of them I'm going to show tonight that were sort of sitting on the shelf for a year and a half, trying to get JavaScript to work. So. Yeah.
But I want to thank you for this, because, as a kind of backend programmer who wants to go into front end, I think it's a great option, and I think the fact that a lot of people made this effort to be compatible at least gives it a big chance, right? And kind of pushes it forward. And so, so the kind of wrap-up question I want to ask you is, you go to all these conferences, you know what a lot of people are doing, right? There's just, Scala test users, basically all kinds of, Scala tribes. So what are your kind of learning plans? What do you want to kind of learn next year, and not necessarily like bring it to the Scala test, but what are your interests in where Scala is going, right? Like what do you want to catch up on, and maybe use some of this in Scala test, maybe not, but like what's interesting to you?
I'm a year behind. I want to learn about free monads.
All right.
So
let's match it to us.
I think that I find it hard to understand their code, but it's actually, if you can avoid mocking, it's actually about testing, right? It's a way to do something that you describe what the side effects are going to be, and then you end up with data structure with a for expression that's kind of natural for Scala, I think. And then you can just test it, make sure it looks like it's supposed to, and then you interpret it. But it's all, the other part about it is it's slow. Is it too slow, right? So I'm just kind of curious about that, because it's kind of related to testing in that way. But I just take a step back. Like last week, I had so many fascinating conversations with people, and I learned a lot. And they were mostly the CATS folks. And,
no, CATS are great.
Yeah, because I'm not from that world, and so I have a lot to learn there still. So that might be a little bit.
And it's great that they're local, right? So Stu, Connor, Ricky, and Albert Chang, they promised, to give more talks. So maybe we can both come and ask them a bunch of questions.
All right.
All right. So let's make it a plan.
Okay.
Okay. Thanks, Bill. So looking forward to your main talk, and thanks again for coming.
Thanks.